All right. First things first. So we're going to use, we're finding the local max and min, and we're going to use the second derivative test where it applies. All right. So let's do A. Well, first things first, let's find our first derivative. Well, that's going to be what? That's going to be a 3x squared minus 18x plus 24. Now, we need to find critical numbers. So that means we have to factor. So if we pull out a 3, that's going to make it a little easier. So that's going to be what? X squared minus 6x, and then that's going to be plus 8. And so that's going to be 3 times x minus 4, x minus 2. And so, oh, and so we're going to have x equals 2 and 4 are going to be our critical numbers. Okay. Um, and so here, f of 2 is going to be what? Well, we plug in 2 into that and we actually get out a 10. And if we plug in f of 4, we plug that in, what we're going to get out is a 6. Now, are they, you know, both going to be going up? And so one's the local min and or local max and one's the local min, or are they, what are they? So what we have to do is we have to use our second derivative test. And so then that gives us what? Well, that gives us 6x and then minus 18. Well, if we solve this equal to 0, 6x equals 18, x equals 3. And so what we have to do now is we have to figure out what, that's kind of just to get a critical number. And now what we have to do is we have to set f double prime of our 2 and our 4 and figure out what they are. Well, if we plug in 2, that's going to be negative. So, I mean, it's going to give us a negative 6. So it's going to be less than 0. So that means it's going to be a max. Okay. And if we plug in 4, that's going to be 24. So that's going to be a positive 6. That's going to be greater than 0. So that's going to be a min. And these are going to be local. Okay. And so that's what we're going to do. We're going to find the local min and local max. And so that means that this one here is the actual what local max. And this is going to be our local min. And again, we didn't draw a picture, but that's how we got it using our second derivative because we had the less than 0 and we had the greater than 0. And so if we go back to our table, uh, less than 0, it was going to be a local max. Greater than 0, it was going to be the local min. All right. So let's do B. B, taking that derivative. So f prime of x is going to be what? Well, derivative of e to the x is e to the x. Derivative of that's going to be a minus 5. Now this one's going to be a little more complicated because then what we have to do is we have to take and set this equal to 0. So e to the x is equal to 5. After we set it equal to 0, take the 5 over. Now we want to solve for x, so that means we have to take the ln of both sides. So we have to take the ln here, we have to take the ln of here. When we take that, the x comes down in front, so we get x equals ln of 5. Okay, so that's going to be our critical number. Okay. And I'm going to leave it as ln of 5 because that's just going to be easier to do than put it as 3 decimal places or whatever. That's not going to be as exact. And so if we do that, then f of ln of 5, and I've already calculated this because it's a funky number like this, is going to be what? Well, that's e to the ln of 5, and then it's minus 5. And guess what? That equals 0. And so we have that to do. Now, what are we going to do now? Well, we're going to find what f double prime is of x. And so the derivative of this, well, that's just e to the x. So that's not too bad. So then if we plug in our ln of 5, that's e to the ln of 5. Well, that just gives us 5. And that's going to be greater than 0. So that's going to be a local min. And so this says that this is going to be a local min basically over here for our ln of 5. Okay. And so that's using again the second derivative test to get to that point. All right. So the next one We can do over here maybe. Let's do C here. So if we take that derivative, we're going to bring that down. So that's going to be what? F prime of x is equal to 60x to the fifth minus 5 times that's going to be, looks like 120 x to the now 4. And then 4 times that's going to be plus 60x to the 3. All right. Looks like there's a 60 we can pull out and an x to the third we can pull out. And when we do that, that's going to give us what? X squared minus 2x plus 1. And so that's going to be 60x cubed, and that's going to be x minus 1 and then x minus 1. So we're going to have two critical numbers, it looks like. We're going to have x is equal to 0 and x is equal to 1. Okay. Well, f of 0 equals what? Well, that's going to be 0. That's pretty easy. And f of 1 equals what? So that's going to be 60. And so it looks like f of 1 is going to be, well, it looks like it's going to be, wait, 1 times 60 minus 120. That looks like it's going to be 0 as well. Hmm. Okay. Okay. Oh, oops. I'm putting that back into the derivative, not that. So let's go back here. I'm putting that in the wrong one. I know it's going to be 0 when I plug that one in, but when I plug in 1, that's going to be 10, 15, and so it's going to be 25 minus, it's going to be 1. Okay. That makes more sense. I was like, wait, both can't be 0. All right. So putting in the right one, we have to get the right equation to plug it into. All right, so what about our second derivative? Well, that's going to be what? 300 x to the fourth. That's going to be 4 times that's going to be what? Minus 480 x to the third. And that's going to be plus 180 x squared. All right, so that's what we have here. So now we're just going to do the same thing we did before. We're just going to plug in our values, f double prime of 0 and f double prime of, in this case, 1. So 0 is going to give us what? 0. And 1 is going to give us, well, that's going to be 0. All right, so this one, guess what? If we remember, when we get 0, 0, that test does not apply. So for this one, it does not apply in either case. All right, so that means we have to go back to this one up here and use the first derivative test. And so then we have to go and do our number line. So we're going to have 0, 1. Those are going to be our zeros. Now we have to test. Let's test a -1, a half, and maybe 2. All right, and so this is at the f prime. So if we test a -1, that's going to be a -60, -60. And so that's going to be negative, it looks like, in this area. If we plug in a half, that's going to be, that should be, it looks like a positive. And if we plug in 2, that's for surely going to be positive. And so it looks like at this point here, we have a switch. And we're going from negative slope to positive slope. So that means that this is going to be what? A local min. Okay. So we're going to get then on this one, a local min at what? Well, we're going to have it at 0, 0. So that one is going to be our local min. Okay. So this one, we had to go a little further. We did our second derivative test. It doesn't apply. So then we had to go back up to our first derivative test and figure out what that was, find out where it changed sign, and then that was going to be our min or max, depending on which direction things went. So in this case, it was the min. All right, so let's stop there and we'll come back for some more.